Imagine traveling to another star within your lifetime. For decades, this was a dream confined to the realm of science fiction. But today, with groundbreaking advancements in light sail propulsion, interstellar travel is no longer a distant fantasy. It's becoming a tangible reality. Interstellar travel has always been one of humanity's greatest aspirations, but the challenges are monumental. For context, Voyager 1, the farthest human-made object from Earth, launched in 1977. Even after decades of travel, it would still take over 70,000 years to reach our nearest star system, Alpha Centauri. Traditional propulsion systems like chemical rockets and even advanced ion propulsion simply can't cut it for these vast distances. Think of a paper boat floating in a bathtub. Instead of pushing it with your hand, you use a hairdryer to blow air at it. The force of the air pushes the boat forward. Now, imagine replacing the air with light. That's how a light sail works. Light sails rely on radiation pressure. When light particles or photons hit the reflective surface of the sail, they transfer their momentum, pushing it forward. Over time, this small but constant force builds up, allowing the spacecraft to reach extraordinary speeds. The idea of light sails isn't new. It was first proposed in the 1970s by physicist Robert L. Forward, but back then it was more of a thought experiment than a practical concept. Today, thanks to advancements in nanotechnology and laser systems, this once theoretical idea is becoming a reality. In 2016, the Breakthrough Starshot initiative was launched, backed by visionaries like Yuri Milner and the late Stephen Hawking. Their goal was to send a fleet of tiny spacecraft propelled by light sails to Alpha Centauri, our closest neighboring star system, within a single human lifetime. These spacecraft, no bigger than a microchip, would use ultra-thin reflective sails powered by ground-based lasers. At speeds of up to 20% the speed of light, they could reach Alpha Centauri in just 20 to 30 years. While the concept sounds simple, the technical challenges are immense. Recently, researchers at Caltech, led by Harry Atwater, have made significant progress. They've developed miniature light sails made from silicon nitride, a material just 50 nanometers thick. These sails are strong enough to withstand intense radiation and heat while being lightweight enough for propulsion. Using a cutting-edge tool called a common path interferometer, the team measured the sail's movements with picometer-level precision. This allowed them to understand how the sail reacts to radiation pressure from lasers, a critical step in moving from theory to practical application. The team didn't stop there. They also tested the sail's response to lasers hitting it at various angles, simulating real-world conditions. They discovered that when the laser beam isn't perfectly aligned, some light scatters at the sail's edges, reducing forward force. This insight is crucial for optimizing future designs. To address these challenges, the researchers are exploring nanotechnology and metamaterials. These innovations could help stabilize the sail, keeping it aligned with the laser beam for consistent acceleration. Light sails don't need onboard fuel like rockets, achieve higher speeds than ion propulsion, and avoid the safety risks of nuclear systems, making them an efficient choice for interstellar travel. Light sail propulsion isn't just a technological innovation, it's a revolution in how we explore the cosmos. For the first time, we could send spacecraft to study exoplanets in detail, search for signs of life, and perhaps even pave the way for humanity's future expansion beyond our solar system. In short, light sails have the potential to transform our understanding of the universe and our place within it. The journey to perfecting light sail propulsion is far from over. Researchers are now focusing on refining sail materials, improving laser alignment, and testing larger prototypes. Interstellar travel has always seemed impossible, but with light sails, it's no longer a question of if, it's a question of when. Subscribe to our channel for more updates on groundbreaking space exploration technologies.